Good. Good afternoon, Miss. Good afternoon, Mister. We have to talk about of the test of actual pricing with stand varying expected with premium and market bias. Introduction. Different studies provide evidence that expected return change over time with information. This paper presents a new model of a financial valuation model in which expected return are allowed to vary over time. Thereby conditional market betas to vary as well. Is ours conduct the using weekly in excess of the treasury bill rate. This doesn't register in a single week premium model if the premium is considered to be a market factor and is allowed to be vary over time. The formulation of multivariate pricing with varying expectation. The focus of the paper of the following: the multivariate relation for assets which of expected excel return. You can see in the following model where 80 is expected excel return of the difference between rates of return and risk-free rate. There are three hypotheses. A special case. The first special case is conditional mean variance of the weight, the values weighted. Its side, the hypothesis is k equal 0 and alpha t is not to equal to. The first special case is the special CPM, where betas is B times WT. The second case is when the market weighted is don't enter to pricing equation. The hypothesis is k equal 1 and alpha t equal to 0. Its side expected returns are consistent with excess arbitrage pricing with k factors. Their case is when k and alpha t is not to equal 0.
Now I'm going to talk to you about the methodology used for the study. The study applies maximum likelihood method to a full time series and cross-section of return, adjusted from unconditional time to a framework with changing expected return, assuming that the unexpected component of the expected return are normally distributed with mean 0, variance b, and that are independent over time. Then the log likelihood function can, for observation t equals 1 to t equals t can be written in this way, where the factors are the same that were explained in the first part of the presentation. However, the structure provided by the first equation, D, is not enough to bound the likelihood function. For this reason, it is necessary to assume that the expected return moves smoothly enough over time to be approximated to a step function. Under this contract, and letting alpha t equals 0 for simplicity, and k and the vector of expected step return et as a two-asset economy with k equal 2, where k is set equal to the number of test assets, the vector et can vary over time in a two-dimensional space. This scenario is represented in this graph, where x's are the sequence of weekly returns for a 10-week period, and the solid curve is the time path of expectation. similar enough to whom this methodology is valid. Now I'm going to talk to you about the data. For this study, we're using a return on common stock for a 20-year period obtained from the Center for Research in Security Pricing at the University of Chicago. The test assets are 10 portfolios of stock from the New York and American Exchange. The assets are ranked by market value at the end of each year and are assigned to the side for the next year. Portfolios are value-weighted portfolios of the firm in each design, where the weight changes every week. Finally, the table 1 presents statistical results for the weekly return and the relative market value, with SD, the standard deviation, and row 1, the first order autocorrelation.
The empirical results. The constant parameters of the model are held fixed on 4 256 week periods, and for each subperiod were tested the 3 hypotheses. Letter A, k equals 0 and alpha t is not equal to 0. Letter B, k equals 1 and alpha t equals 0. And letter C, k is less than or equal to 1 and alpha t is not equal to 0. Simulation process are realized to investigate the behavior on the statistic test. And the first set of experiments examines the behavior under the null hypothesis. For each hypothesis, there were conducted 3 trial simulations, and each trial used the estimated parameter models. The table 2 presents the summary statistics for samples of simulated statistics tests. And it's possible to know that the means and the standard deviation and the most of summary statistics are very similar across the 3 trials for each test. And it's possible to attribute this to the use to the normally distributed disturbances. The table 3 show in the right hand column an overall p-value and the mean of the 4 sample value is compared with the null distribution and assuming normality. The overall test reject the conditional mean variance efficiency at the 3% level, and it produced largest p-values in the other hypothesis. This rejection can be consistent with the CAPM model because the true market portfolio is not measured, and the tests are conducted in subset of assets. The evidence above show that the mean variance efficiency of the value weighted index can be rejected, and this rejection can be insensitive to the variability to the expected risk premium. It's possible that the exact single premium pricing hypothesis is not rejected because the tests have low power, and a single risk premium model of expected returns is not rejected if the premium is allowed to vary over time and if the risk measure associated with that premium are not constrained to equal to market betas. And that's all.